Hi. Okay. This is going to be an attempt by me to try to create a asynchronous class for the college course, Math 115, for Wednesday the 23rd, which is tomorrow, so that we can see if this is enough for you to understand what the lesson is. So today's lesson is going to be about absolute value inequalities, and I took the liberty of opening up the 6 problems for myself that are similar to the problems you're going to run into when you do the exercises yourself. And I'm going to see how well it works, and there's going to be some pluses and minuses, of course, but we'll see. All right, so just give me feedback if you can. Send me an email if you think this is useful or not. So let's get started. Okay. First thing I'm going to do is I went to Lumen and I opened up the homework number 1.3, homework number 2, which is absolute value inequalities, and you can see that my first problem is the absolute value of 4x minus 8 is less than 6. So if I go here, I'm going to start working through this problem, and it should not be overly complicated, because one thing you'll notice is that it's very similar in structure to the original problems that we did do in class together, or you did do by yourself. So I'm going to begin by noting that it's 4x minus 8 less than 6. Now, if this had been an equal sign, you would have done equals 6 on the left and equals negative 6 on the right. Same thing's going to happen here, but there's only going to be one difference. So I'm going to start with 4x minus 8 is less than 6, because that's the original problem. And here, I'm going to do something slightly different. I'm going to do 4x minus 8. And if you'll remember what we did, the right-hand side would become the opposite sign. So that's going to stay the same. Now, the only thing that happens is that this inequality will in turn flip around to the opposite direction, so it's greater than negative 6. And actually the same thing is happening when you do the equations, except that when you flip an equation sign upside down, it's the same thing, so you don't see it happening. And then you solve like you would everything else. So we're going to add 8 to both sides. 4x is less than 14, and that makes x less than 14 over 4, obviously, right? But you should try to get used to reducing whenever possible. So 7 over 2 is the other answer. And, of course, the decimal version of that is 3.5. Okay, so we've got one solution. The other side will work the same. So we're going to get 4x. We're going to add 8 again, but this time it's going to take us to a negative, 8 minus 6. No, it's a positive 2. So let me erase that. Sorry, let me undo that and go back to my pen tool and make sure it's still in white, because otherwise that would be really bad news. And I'm going to make that 8 minus 6, that's 2. And then solving x is greater than 2 over 4. And this is the last time I'm going to do that. I'm just going to go straight ahead to the reduced fraction. 1/2, which is not greater than, it's equal to, and that's equal to 0.5. So like I said today in class, a number of you are happy with doing it in the original way, but it might be better to get used to doing it in fractional form as well. Now, the only thing is, you've got to reconcile two statements. You've got x being less than 3.5, but at the same time being greater than 0.5. So what you've got is a solution where x is between these two values. Okay, so you're going to need to reconcile that, and what you're going to need to do is take note of the fact that you have an inequality less than, not less than or equal to, so you're going to need parentheses. You're going to start at 1/2, and you're going to stop at 7/2 if you want to do it that way, or you can start at 0.5 and end at 3.5. It means the exact same thing, but I think it might be better to just play with the idea of using fractions whenever possible. I'm going to go to Lumen. I'm going to put the answer as an interval here. I'm going to move myself out of the way so you can see that, and I'm going to click in. I'm going to just use parenthesis keys, so that's going to be I can do 0.5, but I'm going to do 1 over 2. I'm going to make sure I hit the right arrow key to get the comma space there. And then I'm going to complete it with 7 over 2. And you can see the parentheses is automatically closing out when you do that. So you should be okay with doing that. And now you have your answer. I'm going to submit. I did click submit, and we got it right. You may not be able to tell, but here you go. It's green. That means we got it right. Okay, and I'm going to continue with this as well into the next phase. So if you want to stay tuned, this is the next question. Absolute value of 4x plus 6 is greater than 4. And you'll notice that when I go here, I actually did this one here too. So here goes. As you remember, you may want to pause this. Actually, now that I'm thinking about it, you may want to pause it and try it out on your own and see what you get, and then compare it with what I do here. So if you want to do that, I'm going to pause right now. I would say pause right now, and I'll meet you on the other side. Okay, so we're back, and if you paused, you solved it. So we're going to do a comparison. I'm going to do the straight through. So 4x plus 6 is greater than 4, but that also means that 4x plus 6 must be less than negative 4. So I cannot stress how much it's important to remember to flip this sign over. If you don't do that, you're going to get it wrong. Okay. Now, I've seen enough of these problems to know that this is going to be a union problem, not an intersection problem. So it's not going to be a number, comma, a number. This is going to involve the infinity symbols as well. So we're going to use this too. 4x will be greater than a negative 2. That means this x is greater than negative 1 over 2. Okay, I think I'm in the way here, so let me move myself yet again out of the way. Hopefully I can stay out of trouble up here. Okay, doing the same thing on the other side. 4x plus 6. Oh, wait a minute. Why am I doing that? Let me just solve it, right? I just need to subtract 6 on both sides. So I don't even need that anymore. So 4x is less than... Oops. I knew that was going to happen, but I did it anyway. So 4x is less than negative 10, which makes x less than negative 5 over 2. Okay. So now you got to think about what's going on here. X is going to be a number less than, just so you can see it in decimal form, it'll make it a little bit easier to read for number line purposes, negative 2.5. That means that everything less than negative 2.5 is going to be true. Okay. On this side, that means that everything greater than negative 0.5 will also be true. But remember, 0.5 is bigger. Okay, so you've got to reconcile those two together into one statement that satisfies everything, and that's where you're going to need parentheses and brackets and infinities. Now, you're going to not use any brackets at all in this problem because of these two signs. You're going to have a specification. If a number is less than negative 2.5, then on a number line, if you remember what's going on here, on a number line, then negative 2.5 would be here. It would be everything back here. Okay. On the other hand, negative 1/2 is here, and it's going to be everything bigger than that. So there's a gap in the middle where it doesn't work. Okay. But you do have to remember that it's going to require everything less than that and everything greater than that. That means you're going to need the infinities. And I'm going to change the color of the pen so you can see what I'm going to do here. Following this as a guide, I'm going to begin with the leftmost value, which in this case will be negative infinity. I'm going to comma that, and then I'm going to remember this is going to be negative, okay, 2.5. I guess I'll leave it there right now this time. Okay, and then I'm close it off because after 2.5, negative 2.5, there's nothing here. That won't work. Okay, and nothing works until you go past negative 1/2. So that means you have to begin, I'm going to run out of room here, at negative 0.5 and continue into infinity and close the parentheses, which I'm not going to be able to show that well. Okay, now you got to remember that because it is both of these and they're not touching it there, they're not intersecting, you need to couple them together. You need to unify them. So you're going to need that letter U and put that in the middle. So your answer is going to be negative infinity, comma, negative 2.5 parentheses, and then union sign, and then negative 0.5, comma, positive infinity. I know it's messy, so I'm going to actually put it into Lumen the way it is right now. Okay, so that means that we need to use our keys for this one. And it's got everything we need here. So I know I need a collection of this. I guess I could put the union symbol in here if I can figure out where it is. Oh, here it is. U. It says use the letter U. Okay, so I'm going to use the letter U and put that here. I hope that works. I'm not sure about this. Let's see. This got to. Oh, wait. It might be functions. Nope. Interval. There you go. There's my U. That's the one I want. So I want to use that instead, not the capital letter U. That would have been crazy talk. And okay, everything I need is here. I'm going to begin with negative. Not here. Sorry. I'm going to begin with negative infinity because it begins at negative infinity. I'm going to comma that, and then I'm going to end up at, what was my number again? Negative what? Negative 0.5. No, sorry, negative 2.5. Okay, so it's going to be negative 2.5. And then I'm going to start off again at negative 0.5. Comma that, and I'm going to go on into positive infinity. Then that's telling me that everything to the left of negative 2.5 is true, but everything to the right of negative 0.5 is also true. And I think that's my entire statement here. Submit it, and we got that right. Okay, I'm actually feeling good about this now.